So we said that 2 meant it translates 2 units to the right. The -4 says it translates 4 units down. Now, is yours all messed up like mine is?
Yeah.
Oh, that's a bummer. Okay. All right. Oh, and that one is too. Okay, so, and the 1 was not a change, so there was no transformation to make in there. Okay, so we need to remember that this is starting from our parent graph. Our parent graph is always going to have these, what we call the Fab 5, -2, -1, 0, 1, and 2, okay? Those 5 middle x coordinates. And then if we put them in where y equals x squared, so if we do -2 squared, that's where we got this 4, which is my y value right here. If we do -1 squared, we get 1. 0 squared gives me 0, 1 squared gives me 1, and 2 squared gives me 4. You guys okay back there? Somebody need notes? Do you need notes? There is in the top section above that goldenrod paper over there. All right. Now, what we are doing is we are going to now be moving. Actually, let me back up. Let's go ahead and plot these points. Okay? So, -2, 4 on your paper. Find -2 and then up 4 is going to be that point there. So we are plotting the points over here in the black folder. And right above that yellow paper, that is, yeah, right there. So that is -2, 4. Then we're going to plot the point -1, 1. And that's not even -2, 4, is it? -2, +4. Then we have -1, 1. We have 0, 0, 1, 1, and 2, 4. Make a gentle curve so it makes a parabola. And this is f of x, your parent function. Okay? F of x, your parent function. Now, we have this new function, which was g of x equals x minus 2 quantity squared minus 4. The h value that we already found, we said was 2. So we are going to add 2 to all of these x values from the parent function. Okay? And that's going to give me my new x coordinate. So 2 plus -2 is 0. 2 plus -1 is 1. 2 plus 0 is 2. 2 plus 1 is 3. And 2 plus 1 is 4. Those are my new h coordinates. Okay? New h coordinates. All right. Over here on the right, up at the top, it says we need to take y times the a value and then add the k value. My a value in this case was 1. So I need to multiply my old parent function y coordinate times 1. And then I'm going to add k, which in this case is subtracting 4. Okay, subtracting 4. Now, you gotta tell me now if you are totally lost as to where I got all these numbers. Okay, which set of numbers would you say? Okay, so these that were written right here with the red arrow here, whoops, red. These were the parent functions. So your parent function is never going to change. It's always going to have a vertex of 0, 0. It's always going to have points 1, 1, negative 1, 1. And it's always going to have 2, 4, and negative 2, 4. Okay? You're always going to start with your fab 5, negative 2 to 2. And then you can substitute these in to get your y values. Okay? Yes?
So with the plus 2 and negative 4, that should be that on the vertex, right?
Yes. I get it from the a value that's here and the k value, which is here. Now, going back to what you were kind of looking at too, my h value is 2 because it's the opposite. And this at the top says we take h plus our x value. If it moves it 2, it's going to move that x coordinate 2 places to the right, which means it's adding 2 to the old parent function. So that's why we get 2 plus the old parent function. That gives me 0. 2 plus negative 1 gives me 1. We do the same thing for my a value and my k value. And now we just have to simplify that to give me my new k values. So 4 times 1 is 4. 4 minus 4 is 0. 1 times 1 is 1. 1 minus 3, or 1 minus 4 is negative 3. 0 times 1 is 0, minus 4 is negative 4. 1 times 1 is 1, minus 4 is negative 3. And 4 times 1 is 4, minus 4 is 0. So a couple things you should notice here. Again, because this is a parabola, your y values, or in this case, your k values, for the outside ones are going to be the same, and then the second and fourth points are going to have the same y value, okay? Because they're either both going up or both going down. Also, the middle one is always going to be your vertex, okay? So we plot these values now over here. And so we've got 0, 0 right there. So they both share that point. We have 1, negative 3, 1, and then 3 down. We have 2, negative 4, 3, negative 3, and 4, 0. So this is my new parabola, g of x. Okay, so this is g of x, and we should label it because we want to know which one's the parent function, which one is the new function. And as you look at it, it is pretty much the same size, but it was translated 2 units to the right and 2 units, no, not 2, 4 units down. So it's as if we took this whole parent graph and said, let's move everything 2 units to the right and 4 down. Okay? That's what we are doing when we are creating these new quadratics. Questions about that? All right, I'm going to have to try to find the original notes for this next one. And we need to talk about the transformations here. So as I'm looking this up, can you go ahead? No, we already did that. Translations, never mind. All right, let me see if I can find the original notes. Here we go. All right, so let's go to the next one. We're going to crunch it in a little bit. Okay. All right. So the first g of x, and you're going to write this in because it didn't show up here. Not a lot of room. I'm going to do it right here. So g of x, this is the function that was moved, is going to be -2 times quantity x minus 3 squared plus 2. And they want to know, how is that different from the parent function of f of x equals x squared? Okay. So we have our a equals, our h equals, and our k equals. So I'm looking at this right here, g of x. Okay. What is my a value? Anyone? No, we're looking at g of x right here. I'm sorry, it's a little mashed up. -2. Does everybody see that? So -2. My h value, remember, opposite, +3. And my k value is 2. So it's -2, 3, and 2. Okay? So let's go over to the table first. Over here. And we have the h value of 3. So h over here, h is equal to 3. So I'm going to add 3 to all of these x values. Okay? Add 3 to all of these x values. And before I go on, let's go ahead. Here's my x values. Here's my y values for the parent function. So -2, 4. -2, 4, right there. -1, 1. 0, 0, 1, 1, and 2, 4. Miss Thede, are you telling me that parent function is always going to be the same? Yes. It's always going to have and look exactly like this. So this is f of x. TJ, can I talk with you after class? Okay. So this is your parent. And we are working on g of x. Now, my a value is -2. So my a value here, I'm going to multiply by -2. And then I'm going to add my k value. And the k value is +2. +2. So you definitely want to have a table when you're doing this. And we will help you and get that structured for you. All right, so let's find now our new and improved h values. So 3 plus -2 is +1. That's my new x coordinate. 3 plus -1 is 2. 3 plus 0 is 3. 3 plus 1 is 4. And 3 plus 2 is 5. What do you notice about our new h coordinates from this point and in the last example? They're always what? Okay, they might always be positive, and they're not always going to be positive, but they're always consecutive, right? Because you are looking at the points that are the 5 points that are together. So they're always going to probably differ by just 1. Okay. All right, let's find our new k value. So we take, following order of operations, 4 times -2 is -8, and -8 plus 2 is -6. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. 0 times negative 2 is 0, and 0 plus 2 is 2. 1 times negative 2 is negative 2 plus 2 is 0. And 4 times negative 2 is negative 8 plus 2 is negative 6. Remember, your first and your fifth points are always going to have the same y coordinates, and your second and your fourth points will always have the same. So if you don't end up with the same values, you've done some math incorrectly. Okay? All right, so now let's plot these points right here and see where our new function is. Okay? So I want 1, negative 6. I want 2, 0. That's right on the x-axis. 3, 2. 4, 0. And 5, negative 6. Okay? Pull those together to make the shape of a parabola. Please put your x, or not x values, your arrows on the ends, because they would continue on. Label it as g of x. And you can tell that it was, we didn't do the transformations, did we? Well, first of all, we could say it flipped over, but we don't say it flipped over, and we don't say it opens downward. What do we say? Reflected across the x-axis. And this pretty much is your transformations. So I'm just going to write transformations here. These are your transformations reflected across the x-axis. My A was a negative, so that takes care of the negative. The 2 says it is a vertical stretch of 2. Vertical stretch of 2. And remember, that's downward, right? We also have, since our H was 3, that is translates 3 units to the what direction? If it's your H, you're going horizontal. Is that to the right or to the left? If it's positive, to the right. Translates 3 units to the right, and translates with a positive 2 to K2. Okay, 2. 2 up. That's weird. I guess because it's turned upside down, it is 2 up, but upside down. Okay. All right. Whew, that is a lot of writing, is it not? In a small space. So I do apologize for the notes being all scrunched together. That is all the notes that we are doing for today, okay? You still have your homework, so you should be able to do a little bit more of the problems in 12-2 for the homework, okay? We've got about 5 minutes. I totally understand if you want to chill, though. I really want to chill, like in a freezer. So remember, our next test is next Friday, 1 week from today. 2 more days of notes, and then 2 days of review and the test. All right?